आप अपने घर पे चेक कर सकते हैं। मोबाइल पे डाउनलोड करो तो मोबाइल से दिखा डाउनलोडिंग को देखना है आप लोग लोड होगी सर्वर के फोटो बदलाता लगेगा।
I would like to invite Director of Biotechnology, Professor Padmabhushan ma'am, for the ceremonial floral welcome of the esteemed guests. Thank you, ma'am. I would like to invite Director School of Biotechnology, Professor Padmabhushan ma'am, for all welcome.
Ladies and gentlemen, distinguished guests, and members, it is a privilege to welcome you all to this special occasion as we gather here to listen to this insights on eminent. At the outset, on behalf of the School of Biotechnology, I'd like to place my welcome to Padmabhushan Prof. Balaram, former director IISc and chairperson at NCBSin Bangalore. I also place a warm welcome to Professor Balaram, who is in the department, and who is a professor at JMCS. A very warm welcome to Professor who has been associated with the department since very long time, advising us, and we all look forward to his special remarks. My special remarks of welcome to Professor Department of Chemistry, Professor who is on the desk, Professor Professor Head Department of Botany, and also President IISc. My welcome to the other dignitaries sitting over there. I see Professor Dr. Gandhi from Botany, and the faculty from other departments, also from colleges. I'm sorry I don't remember the names, but a very warm welcome to all of you. A welcome to all students who are here from departments of life sciences, chemistry, and science of university. Before we start, sir, about our department, that is biotechnology. This was established in December 1998 with funding from the Department of Biotechnology, Government of India, and admission to this program of MSc Biotechnology is based on the graduate aptitude test which is being conducted by the Regional Center for Biotechnology for Hyderabad. And the first batch of students was admitted in the year 1999. And so far, more than 300 students have graduated from this department. Students, they are able to clear national tests like NET JRF, CSIR, UGC, NET JRF, NET JRF, ICMR, and other examinations of national importance. The students have been placed in the most prestigious research institutes across the globe for pursuing PhD programs and also for postdoctoral studies. Here, I would like to mention the first batch of our students who graduated from here. Almost 50% of them, they did their PhD from the IISc Bangalore, sir. So we are very proud that someone is having the alumni of IISc Bangalore now. The school follows the course curriculum as prescribed by the DPT for MSc Biotechnology. We have 3 MSc laboratories for the students, 2 central facility laboratories, and apart from that, we have research labs which cater to the PhD programs. The school has been awarded with DST FIST, DST PERS, and DUSA funding from MHRD. We have the sophisticated high-end instruments, and we would like you to go around the school to have the glimpse of the facilities that we have here. The school has a very active faculty, research students, and staff, all contributing selflessly to the growth and development of the school. The research interests of the school are ranging from plant microbiology, microbial genomics to cancer biology, fungal biotechnology, industrial enzymes, bioactive compounds, natural product chemistry, metagenomics, and metabolomics. A wide-ranging research interests are fortunate to have him here among us. His presence will provide a unique opportunity to expand our intellectual horizon. But let us not forget the significance of this gathering as a whole. We have students also here, and I wish that you, dear students, who are a lifeblood of our institution, your passion, enthusiasm, and thirst for knowledge are the driving force for the progress we make in our own field over here. I encourage you to make the most of this opportunity to listen attentively and to engage in thought-provoking discussions. With that, I once again extend my warmest welcome to our eminent success, Professor Balaram, faculty members and students. Let us embrace this occasion as a celebration of intellectual pursuit and the power of human entity. With these words, I request Professor Balaram to please deliver his invited lecture.
Good afternoon. I hope you all had lunch and in fact to listen to the lunch. I agreed to come to Jammu on Professor Prof's very kind invitation. I asked him what we could deliver a technical talk about something that I'm doing in addition to the more general lecture that is morning. In response, Professor Paul told me, can you talk about science community? And this is something that may be of interest. I suspect this is largely because of the many years that I spent writing about science and scientists in the journal that I edited at that time. I have a number of general lectures, and most of these lectures have intended to convey scientific ideas and scientific advances to general audiences. And sometimes it's not very easy to convey science to a general audience. They are receptive, but sometimes we are not able to explain things in the way that a non-scientist can understand. So I'm going to title my presentation as Science Communication and the Public Understanding Science. You looked at this cartoon for some time now, so you can see what the cartoon is all about. It's of course a husband and wife who've been married for many, many years, now sitting in total silence. And then of course one of them says that the nicest conversation we've had in weeks, let's not spoil it by talking. What is science? On the periphery of the slide, I have of course put the pictures of some scientists. Most of them from the period between the 17th, 16th, 17th and 18th centuries, when in the West there was the Southern Renaissance of science, beginning of course with Copernicus and Harvey. Harvey is the man who gave us the second blood, and then of course later on to more useful things when Jenner got smallpox vaccine, and of course Darwin. Now I read this article 2 or 3 years ago in Scientific American, which was entitled The Science Tool. After I read the article, I prepared this illustration, once again by using Google Images. What would a science tool be? It would be a stool like this, which would rest on 3 legs. What are those legs? The first one is data, the second one is theory, and the third one is communication. So you must have data, you must have theory which explains the data, and then you must be able to communicate this to the world. As far as I'm concerned, I don't see any better example of this than the work, for example, of Darwin. Now, what did Darwin do? He went on you don't need to have any particular background in order to read it. It's only today, after about 150 years, we've categorized ourselves into chemists, physicists, biologists, mathematicians, and so on. So we say that's a book that only biologists should read. But in Darwin's time, there were no engineers, in fact, at that time. So everybody was a natural scientist. So anybody could read this. And so he very successfully communicated his ideas. Now in India, we have 2 days on which we celebrate science technology. The first one, of course, is the 28th of February, where we celebrate Raman's discovery of the new light scattering effect, which now is phenomenal. Then we have in the month of May, we celebrate National Technology Day, which is the day of the Balaram to atomic explosions. So you can see that celebrating science and technology. In Raman's case, it was a discovery, and it was a discovery of it was a very important discovery at the time when Raman discovered this, the fact that the frequency of scattered light from liquids, that the frequency of scattered light was slightly less than the frequency of incident light, the energy that it lost had been captured by the molecule in a exciting or vibrational transition. And therefore, you were now able to use a lot of study molecules. Even more importantly, at the time that he discovered it in 1928, was in fact direct experimental proof of the quantum theory, which was now simply taking over physics at that time. Which is why the Nobel Prize was given within a couple of years after the announcement of the Raman effect. Now, the public understanding of science is important, and nothing is demonstrated this more than if it was material. Now, here, of course, are 2 largest democracies of the world, and also 2 of the countries of the world where the press is also quite trying now to eliminate the coronavirus. On one hand, you have Donald Trump prescribing bleach, and on the other hand, you have corona now prepared by our own Balaram and company. Now, do these actually work on the coronavirus? It actually turns out neither of them works on the coronavirus. And almost practically nothing is working on the coronavirus. That's why I put this cartoon that in case you are not able to read it, I'll leave it for the people who are at the back of the hall. Now, there's this guy drinking beer, and he's calling someone and telling them, I read that drinking beer can cure COVID and bring world peace. And then he says, probably fake news, but why take a chance? And so it is a rather nice cartoon, which sort of signifies how we approach this. And I carried out a survey some years ago, and I think these kinds of surveys are not carried out today. The result is very interesting. It is carried it out only in the population who are in higher education institutions and ask them these questions. So they asked many questions, and they found that there was a large difference between the response of US adults and scientists who are members of the American Association for the Development of Science. For example, only about 50% of people believe that climate change is due to human activity, but 87% of scientists believe that climate change is due to human activity. Now, you might still not believe that climate change is due to human activity, but then you wouldn't know. Now, if you've asked whether it's safe to eat genetically modified foods, this is an important question which has to be answered in India as we go along, as the population becomes even larger and you need more food. Should genetically modified foods be available? Only 30% of people in America really said that it's safe, whereas among scientists the number was 88%. So you can see there's a large difference in perception. These are important questions, because tomorrow, if genetically modified crops are to be approved in India, it would become a major subject of political debate. So science is important. But then, of course, we do have science. We do have leaders. America has had Donald Trump, so this cartoon is an American cartoon. So you can see that he said everything is harmful, and he doesn't like many things. He doesn't like environment, immigration, climate change, lots of things which Donald Trump did not like when he was president. And if he comes back, he's not like all those things once again. But I should make this an American cartoon thing, right? So here's one in India. Now this tells you something about the public understanding of the science. Now this is the Chief Minister, fortunately a former Chief Minister of Uttarakhand, Mr. Rawat, who that time made a very interesting statement. I actually read this very carefully because I am interested in oxygen now and in the role of oxygen in evolution. And what he said was that only cows breathe out oxygen. So he now set apart in the animal kingdom the cow as an animal separate from all the other animals that are there. Now the question is, should we believe Mr. Rawat, or is Mr. Rawat's understanding of biology false? Now clearly the conclusion, if you are all students in the Department of Biotechnology, would be that Mr. Rawat's understanding of biology is faulty, and maybe he shouldn't be saying such things. But cartoonist, I don't like this cartoon. This was drawn before the COVID-19 pandemic, 2019. In 2020, if you remember, we had a shortage of oxygen, especially in 21 during the second Delta phase of the pandemic. So there was a cartoonist immediately said that the problem of patients could be solved by just hooking them up to a cow because it was now exhaling oxygen. This is the public understanding of science, sometimes by people who should know better. Why did I show you this slide? I show you this slide again. The only reason I show you this slide that this is a subject which everybody should be taking some interest in. We should be worried about the fate of carbon, because it is carbon which keeps us going. It's carbon dioxide we exhale, and it is carbon dioxide and a number of attendant gases like the oxides of nitrogen and sulfur, which are automobiles, for example, all of which are going into the atmosphere. And it is those gases which are going into the atmosphere which now give rise to the global warming problem. So as carbon dioxide levels build up in the atmosphere, nature itself finds this extraordinary device of coupling plants and animals. One inhales oxygen and exhales carbon dioxide, and the other one takes in the carbon dioxide and converts it into carbohydrate, and we eat the carbohydrate and go through the cycle all over again. This is the global carbon cycle. Now the economy of this cycle is striking. I tell you what wonderful world we live in and how important it is to preserve it. Now, in the introduction, I was struck by the fact that I was introduced as the chairman of the board at the Ashoka Trust for Ecology and Environment. I'm not an ecologist, I'm not an environmentalist, but I'm chairman of the board only because I happen to be there and I'm available. But over a period of time, I've become interested in ecology and environment, read more about it and think more about it. And I think making other people think about the carbon cycle is one way of contributing to the subject. And here's another one. In India, there are two groups of people who actually run the country. One are politicians, and the other are people who sit on the benches of various courts in Latin. So between the judiciary and the politicians, they often make very important pronouncements. And here on the day he was retiring, Judge in the Rajasthan High Court, there is a certain majesty about a pronouncement which comes from a High Court or the Supreme Court, however wrong it is. And here it is. He's elevated another animal, the peacock, to a new level. And he says that the peacocks don't have sex. And how do you think peacocks produce? Justice Sharma says that the peahen gets pregnant drinking the tears of the peacock. Now, any self-respecting biology department even I would say in high school, I think the time is past when we should listen to people like us. So, we need to ask some general questions if we are going to communicate science. Get us what is science, how is science done, and is science useful? Now, I think science is useful, and as I talk, we will find more reasons for agreeing that science is useful. But we must answer the question, what is science and how is science done? In the morning, of course, I tried to answer the question, said science is study of nature, and I simply borrowed Goethe's translation to say that science is the study of nature, and what is nature? Now, if that is science, then we have to ask, how is science done? Now, one way is by observing. And here is part of the problem in our surroundings today. In order for us to make observations, we need tools. Now, for a very long time, the only way we could make observations was with our eyes. We were limited by what our eyes could see. Unfortunately, both innovations, inventions, whatever you wish to call them, of the telescope and the microscope happened in the West. One happened in Holland when Leeuwenhoek got the microscope, and the other when Galileo got the telescope in Italy. And what did Galileo do? He simply pointed the telescope skyward and looked. And suddenly he discovered a world which had been invisible then to the naked eye. So it just added technology to the naked eye. Today, of course, astronomers see with radio telescopes from very, very far out into the universe. What did Galileo do? He took the microscope and put water on it, tap water. And tap water in Amsterdam was as dirty as tap water anywhere in those days. And what he saw was microbes, little things moving down to the water. He discovered microbiology. He found bacteria. And so this tells you the importance of tools. We, of course, have very many tools, advanced tools to study whatever we are studying, molecules, atoms, cells, and so forth. So scientists need tools, but then there are many ways of doing science. One way is observation. This is wonderful. You just look around you, you observe, you collect the information, and you classify it. The true exemplars of observation and classification are Darwin and Mendeleev. Because what did Mendeleev do? Elements were being found. He wrote down all the properties of the elements. And then he began to ask, is there any relationship? And then he began to arrange them. And most importantly, Mendeleev's early periodic table was that when he arranged the properties, he would immediately predict elements which had not yet been discovered. That is the strength of a theory. That is something which is predicting that there is an element to be discovered, and when the elements were discovered, they were based right there. This was many years before atomic structure theory came. Today, of course, we can build the periodic table with S, P, D, F orbitals if you are studying chemistry, by feeding electrons. That was observation and classification. Darwin, of course, I've already mentioned, he classified and then tried to get a systematic hypothesis to explain his observations. The other way of doing experiments, of doing science, you should do an experiment, observe. So you can either observe nature, what other people are doing, or you can do experiments yourself and observe. Pasteur is the man who really did this wonderfully in the 19th century. He did experiments, he made observations, and he's the one who gave us this dictum, chance favors the prepared mind. That is, you want to be lucky to find something. And if you want to be lucky in an experiment, you have to be doing lots of experiments. Because most experiments will fail. So the person who does more experiments has got a greater chance of finding something by accident. I mean, what should hope to find something by accident? But if you don't do any experiments, you won't definitely find anything. So experiments are important. But I think the true example of experiment is family. I don't know how many of you who are students here have done that experiment in school where you have an electric current circulating in a coil and then you put a magnet and the magnet will deflect. Have you done that experiment? Yeah. And then rotating magnet and then a coil nearby and it will light up a bulb. What does this indicate? This is Faraday's famous experiment, and this indicates the connection between electricity and magnetism. When I was in college, electricity and magnetism were taught as two different subjects, even a century after Faraday. And that's one of the sad facts of teaching also, it never changes, and everything's frozen in curriculum. The explanation for Faraday's observation of electromagnetism had to wait for the theory. That came from Maxwell many years later, towards the second half of the 19th century, and Maxwell unified electricity and magnetism. And out of this unification was the most remarkable thing about Maxwell's unification. And you asked me about physics in the morning. I'm a great man of physics. Where electricity and magnetism was out came light. And to get light out of unifying electricity and magnetism immediately taught us that electromagnetic radiation, light is electromagnetic radiation. And the entire field of spectroscopy and understanding electromagnetic radiation. Another person who I would really like to looked at experiments and thought deeply about them, they were all physicists, was Boltzmann. And in Boltzmann's grave in Vienna, you will find that equation written on his grave, S is equal to K naught W. The Boltzmann equation, and the book that I referred to you in the morning, The Ascent of Man, he in fact writes, he's talking about the development of human cultures and the ascent of man. He pauses at Boltzmann, and then he says, to whom more than anyone else we owe the fact that the atom, the world within the world, is as real to us now as our own world. I don't know how many of you know that Boltzmann was the man who thought of atoms first. Chemists who thought of atoms like Dalton and others at that time thought of it really only to explain some things that they were observing. Boltzmann thought of it far more deeply, and he had evidence. What was Boltzmann thinking about? He was thinking about heat. And so even at that time everybody knew that if you had water in a glass and you had a flame below it, the bottom would get hot after some time. So you know that it's getting hot. The question is, what is heat? And Boltzmann said heat is the random motion of atoms. So in this case molecules of water. So the more they move, the hotter it feels. And it is with that idea that he came upon the idea of entropy. And of course the famous book. And he says here, heat is not material any more than fire, any more than light is. Heat is a motion of atoms. When energy is degraded, says Boltzmann, it is the atoms that assume a more disorderly state, and entropy is a measure of that disorder. This is science in action, where you actually get an explanation. Now, my own subject is chemistry, and that is what I studied before I transited to biology. And chemistry has a very bad complication. Chemicals are bad, and everything is bad about chemistry. And the public perception of chemistry, especially in the West and even in India, is like this. But somehow there are some people who understand the word chemistry very well. They are mathematicians. And you can see that all this is another direction. This will be a direction in which Balaram and Nitish are hugging one another. They are hugging one another once again. Everything is cyclical. And they talk about mathematics and chemistry. Again, you ask me, why did I not mathematics? And you see, mathematics is very well understood by politicians. And so is chemistry. Now, of course, how would you describe this picture? You would say, new chemistry, old mathematics. But the unfortunate thing is that our political landscape is dynamic. young, and you will now ask, how will we describe the 2024 polls? What will be the role of mathematics? What will be the role of chemistry? So the public understanding of these terms in science are important. This advertisement comes all the time on TV. I don't know how many times you've seen this. I made this slide some time ago when there was a T20 World Cup on, and I find that it has resurfaced now during the IPL, and this would be this young lady selling swords to the customer, and she would say, you take this pure heavy sword, and very persuasively she would say, it's free of bleachers, chemicals, anti-aging agents, and it has over 80 minerals like iron, potassium, zinc, etc. Now, who wrote this advertisement certainly did not have a good understanding of chemistry. So it is full of chemicals. And of course, salt itself is a chemical. So this problem of tying these chemicals are universal. In America, you have chemical-free cleaning products. And of course, Botany advertises a chemical, so don't use phenol with chemicals in it, I'll provide you something else which has no chemicals. But we're back to the judiciary. About 10 years ago, the Bombay High Court issued a judgment which said steam is not a chemical. A case before them which had been running for some 20 years, in which one industry was producing steam as a byproduct of the industrial process. Either they came to the next plot of land, there was another industry which was buying the steam and using it for heating. So they're selling steam. Now the question is, what is the sales tax to be levied on that steam? The government says steam is not a chemical, so we have a higher rate of tax. The company says steam is a chemical, we want a lower rate of tax. They go to court. The judiciary invariably rules in favor of the government. And especially on tax matters, they always rule in favor of the government. They rule in favor of the government and said steam is not a chemical. This judgment was widely discussed in the chemistry journals. The proposal says steam is not a chemical. And the Royal Society of Chemistry offered a prize of £1 million to anyone who provides a sample of material that's chemically free. Now I'm sure many of you could use £1 million. All you have to do is to go to London with a sample of material which is chemically free. And of course you find that there is no material which is chemically free. Chemistry cannot escape chemistry. And that is the reason why I sort of prefer chemistry over biology and mathematics. But now, to really tell you, these are two subjects with which generally people have a problem. Mathematics and physics. Now, Galileo is reported to have said, I'm not sure about the veracity of this quote, mathematics is the language in which God wrote the universe. If we accept Galileo's statement, I might paraphrase it to say, chemistry is the language with which nature wrote the book of life. So if you want to study biology, then of course you must be firmly grounded in chemistry, because there's no process that's happening in this living cell which is devoid of chemistry. The problem with mathematics and chemistry is this. You need to know structures like that. Those become the alphabets of chemistry, and if you're doing mathematics, you need to have these equations. These become the language of mathematics. So the major trouble in learning subjects is that you need to learn the language of the subject before you learn the subject itself. It's completely descriptive the way you learn biology, and if you learn physics, don't require mathematics up to a point. Only up to a point do they require a great deal of sophisticated mathematics. Which is the concept of motion one can actually understand. So mechanics is easy to teach. I showed you this slide on the importance of chemistry, so I will skip over it. But I show you another cartoon. There's this man doing a crossword puzzle. The question, what's a 9-letter word for biotechnology? That's the department in which I am, I suspect. The phone asks the lady sitting by his side. She's very smart. She gives him the answer immediately. chemistry. That's what you're trying to do. What's a 9-letter word for material science? You know, today we have a lot of this nanomaterials, nanoscience, and nanoengineering. The 9-letter word for material science is again chemistry. That emphasizes the importance of chemistry in the public life. Now, how am I going back? I showed you some of this, but I won't show it to you again. The foundational pillars of chemistry are here. I showed you the foundational pillars of biology in the morning, but the foundational pillars of chemistry are Mendeleev, emphasizes diversity in chemistry. Wohler emphasizes unity in chemistry, that is, inorganic chemistry is not separated from organic chemistry, and organic chemistry is not separated from biochemistry. Boltzmann, a physicist whom I have borrowed now for chemistry, gives us the idea of dynamics, that's where it starts. And Pasteur, who might be called anything, gives us the idea of structure because of his statement on the carbon acids. I showed you this about Wohler this morning. I showed you the slides. I won't do it again. But why do I stress evolution? Many years ago, Dr. Trotsky wrote this article that nothing in biology makes sense except in the light of evolution. Those of you who are students of biotechnology should remember that you get the feeling that biotechnology is a subject in which biology is going to be useful. But in order for biology to be useful, biology must also be understood. And in order to understand biology, you must understand evolution. And one of the things which Advances gets very clearly here is, does the evolutionary doctrine clash with religious faith? Because many Christian religious leaders don't like evolution. Yes, it does not. It is a blunder to mistake the Holy Scriptures for elementary textbooks of astronomy, geology, biology, and anthropology. Only if symbols are construed to mean what they are not intended to mean can they arise imaginary insoluble conflicts. Question now: can basic scientific research lead to useful technology? And can new technologies emerge in an environment which does not support science? Suppose you support only technology. Suppose you say, I want to only get innovation. You're unlikely to succeed. This is something that we must be very clear about. Now look at the Raman effect. This is the 1913 Scientific American, which shows the demonstration of the Raman effect. That's a celebration of the Raman effect. Decades later, I don't think I knew any use for this effect that he died in 1970. There was no application. Even in chemistry, laser Raman spectroscopy did not come because lasers were relatively new. Today, look at the effects of Raman spectroscopy. Everything from airport scanners to finding out what the age of the shroud of Turin is, or even in fingerprinting the universe, you find that Raman scattering and Raman spectroscopy finding it. I showed you two discoveries here. Röntgen was working with cathode rays. Then he realized that if he had the rays and he had a fluorescent plate, he created an image. He called his wife, asked her to put her hand in the beam, and then he created the image. The image that came out was the skeleton of her hand. The reaction was marvelous. She said, I have seen death. And this is true. When you see skeleton, that's what you think about. The physicists did not think much of X-rays. They didn't know what it was. But when this picture was shown, the medical clinicians immediately realized that they had a technique. Therefore, radiology was born. And X-rays became absolutely central to radiology. Many years later, 7 decades later, this experiment was done. 2 concentric tubes of water placed in a magnetic field, and you want to get a nuclear resonance of the protons in water, and you're using homogeneous magnetic fields to create the image. Whoever created this image marvelous image. You could see the tubes. And he called it zoopatography. Today it is what you call magnetic resonance imaging or MRI. So the MRI scan was performed, and Dr. Burke, of course, many years later, won the Nobel Prize. So today, if you go to a radiology department in the medical school, the two techniques which they use have both come from fundamental science. X-rays as well as MRI. Communication is important to people, but I have also found that sometimes it's important to communicate science to scientists. If you can't communicate science to scientists, then you can't communicate science to non-scientists. Because science also is not so specialized. That's why this cartoon, for example, says chemistry for geologists, maths for archaeologists, physics for psychologists, and so on. There are courses now in many universities like this. We have a course where one subject is being taught to students of another subject. And you always wonder, well, why is this so? This is so that they get an idea of subjects in which there might be an interdisciplinary possibility. This cartoon course I rather like because boy asks father, why does ice float? And the father says, because it's cold, ice wants to get warm, so it goes to the top of liquid in order to be near the sun. And the boy asks, is that true? This is post Calvin, and he says, look it up and find out. And then he goes to say, I should just look stuff up in the first place. Now says you can learn a lot by talking to people. Now it turns out that today's students can just look up the internet. You have a question? Except that you should learn to look up the right places and don't get fake information.
You have to push alternate button.
Go back. I showed you this before, and if you go past this,
It is not working on this. The fund is not working on this.
look at the material balance of photosynthesis and respiration. We've done this in class. But what happens when you do it in class, you look at it, but you don't worry about it very much. If you can write it down correctly, then you've got marks for it. So there you have where oxygen is going, where carbon dioxide is going, and so on. But some weeks ago, you would find this thing in the newspapers, that the Union Cabinet has approved the green hydrogen mission. And India has done a green hydrogen mission at a cost of 20,000 crores. What are we going to produce in this green hydrogen mission? We are going to produce hydrogen. And they are going to use hydrogen as the energy to drive everything that we want to drive. But how will we get energy from hydrogen? We have to burn it with oxygen to produce water. So we will be taking hydrogen and oxygen, combining them to get water, a huge amount of energy, and we'll be capturing this energy in order to, this will be green now. There is no carbon dioxide coming anywhere. Where will you get the hydrogen? Where will we get it? Obviously, the guys who are making 24,000 crores should have asked these questions. Where are we going to get hydrogen from? Tomorrow, if we get elected, and then you might need to ask these questions. This is why the public understanding of science is so important. The hydrogen has to become water. Now, water has to be split in order to get into hydrogen. Can we split water? Who splits water? Plants. But do plants produce hydrogen? No. They have got very hydrogen-going plants. It went to reducing equivalents like NADH and so on, which is the biological equivalent of energy. So biology is very economical. It takes away the hydrogen, not in the form of gaseous hydrogen which goes out into the atmosphere, but there's hydrogen in the molecules. And this is why chemistry is. Now this is the problem when we are thinking about problems like this. I showed you this timetable of evolution, and the only thing which I want you to remember is oxygen. Oxygen is hugely important, and we need it for breathing, we need it for respiration. It's transformed evolution. Because once the earth became oxygenated, everything changed. Eukaryotic life seems to be moved after that. I just put my couple back there to emphasize that oxygen is important in many ways, and over time, people have worried about how these changes in oxygen happened thousands of years ago. Certainly they did not happen because of the evolution of cars and due to other causes. I want to show some chemistry. This is from early 12th class chemistry or thereabouts. Bond energies, for example, hydrogen, oxygen, 3 diatomic molecules that one can look at. Biology uses all 3 of them. When we burn glucose, we actually strip off electrons and add them to molecular oxygen. It's the terminal electron acceptor in the electron transport chain. And now, if you want to count the number of electrons that we can add to do the stripping, you can do this from a health transport. You can simply put electrons into the antibody molecules here of oxygen as we understand the structure of oxygen. 1 electron here, 1 electron here. How do I go back? 2 electrons up there, 1 electron up here, 1 electron up here. The bond order will become 0, and now you have the 2 oxygen atoms simply pulled apart, so you need to add 4 electrons. To understand this, you need only this 12th class structure of the oxygen molecule. Now, I will ask you a question. Do you think one should study the structure? Is there anything left to study in the structure of the oxygen molecule? Simple molecule. Almost nothing. But you will find that in science, sometimes this is for scientists, strange things happen. This paper is a 2017 paper in the Journal of the American Chemical Society by the Nobel laureate Hoffman. And he says that oxygen, what makes this structure diradical kinetically persistent? It has a substantially technical title. What he really means is dioxygen has 2 unpaired electrons, and therefore it must be very reactive. Yet it's not reactive. We are happily living with oxygen. Too much of oxygen can be toxic, but the level that we have is fine. How is it then kinetically persistent? How is it thermodynamically stable now? It's not reacting. How does it remain there? And then he says, is oxygen stable in the presence of other elements? The answer is clear or negative. With the exception of gold, every element reacts with oxygen. And in that sense, oxygen is energy rich, and not for nothing is it the choice liquid propellant for rockets. So the Space Research Organization is already using liquid oxygen. And then he said everything can burn. Then he adds here, and I want you to read this. He says we can burn, not just with passion. Of course, we do not burn. So we will also burn if oxygen was reactive, but we don't. The question, of course, then is why does this? What is this barrier to reaction with oxygen? And that's the question which he asks and tries to answer in this paper. So I put this up only to tell you. And even simple molecules like oxygen in the scientific literature, there are still discussions going on. And some of these discussions have a great relevance to biological problems. Here, science needs to be understood not by the outsider. It needs to be understood by scientists in a related discipline for whom oxygen might in fact be important in their work. Now, if you look at the role of oxygen itself in aerobic life, it has so many roles. It's the terminal electron acceptor in oxidative phosphorylation. But it's also the source of oxygen molecules in all biomolecules, steroid hormones, aromatic amino acids, neurotransmitters. from water or does it come from molecular oxygen? Now it turns out that when Conrad Bloch worked on the synthesis of cholesterol, biological synthesis of cholesterol, for which he received the Nobel Prize, he found that it comes from molecular oxygen. What does this lead to? That means before oxygen entered the earth, there was no cholesterol. And therefore archaea and bacteria use other molecules as maintain fluid chemomodulators. And this kind of understanding comes only when you ask simple questions and then try to answer them. And what's most interesting is a very recent issue of Nature carries a paper where they now found a bacterium in which the full biosynthetic pathway of cholesterol appears to be being found. So science, nothing remains static. Things keep changing as people find more. And in the case of oxygen, there's been an explosion of biochemistry after oxygen entered the Earth's atmosphere. The most important thing is here, in the big mitochondrial phosphorylation chain. Here are some students. How many of you have seen this picture? Every one of you should see this picture. Now, this picture, what does it strike you? Is the picture simple? Now, if it's terrible and awful, you should say terrible and awful. It's a very complicated picture. Oxidative phosphorylation is a very complex process in which you have all these membrane protein complexes embedded in the membrane in which electron transfer happens. Remarkable process. Without this, there's no life. No bacteria, no archaea, no eukaryotes, nothing. Electron transport is now universal across all domains of life. Understanding of how this happens is due to Peter Mitchell, who gave the chemiosmotic hypothesis. It is still a hypothesis. It hasn't been elevated to the level of theory because there are still questions about chemiosmosis. But because it's fundamental, there's an assessment here. I showed you in the morning an essay in Nature which talked about the harm of toxins. I showed you another essay in Nature at that time which was titled, Are You Serious of Convention? This is about the mechanisms of energy consumption. And Auger, who wrote this article, said that not since Darwin and Wallace and biology come up with an idea as counterintuitive as say those of Einstein, Heisenberg. So if biology does not have theories like physics, biology doesn't have these sudden flashes of insight. Most things are done slowly, and Darwin is the only one who had that sort of global insight once. But the Mitchell hypothesis for oxidative phosphorylation ranks very high in the minds of other people. So if you want to look at molecules or biochemistry, people have now come down to ask the question, is there a logic in biochemistry? Why are these complex networks the way they are? Here are 8 molecules which Chris Walsh and others have put together. If you understand these 8 molecules and the reaction that they participate, you get a logic of metabolism. How many of you study a biochemistry course? And in the biochemistry course, how many of you study metabolism? The number of hands will get slower and slower. But unfortunately, metabolism is central to biochemistry. And it's one of the wonders of biochemistry. And genes and other things control how all this happens. But eventually the chemistry here is absolutely fascinating. And so these are molecules which he calls genetically stable but thermodynamically activated molecules that are cell metabolism. that cellular metabolism is energy. You must understand energy. And if you need energy, it must be stored in molecules and released at the right times. If it's stored in molecules, it's stored in all these molecules. Oxygen among them. Lastly, I'll show you a book. So when you say science communication, there are many ways of communicating science. One way is done here marvelously by Carl Gerasi and Hoffman, who wrote a book on oxygen. What is this book about? There were three people who actually found oxygen. Lavoisier, Priestley, and the Swedish chemist Carl Scheele. All of it happened around the same time. Now the question, of course, is, they've written a play. This is a play now. They've written a play in which the Nobel Foundation has decided to now award posthumous Nobel Prizes to scientists of the past. So they start now with the 18th century, when chemistry began. The question is, oxygen discovery is the most important event of the 18th century. Who should they give the Nobel Prize to? So Lavoisier, Priestley and Scheele, all three of them appear in this play. All three of them make their case. There's the usual kind of politics on who should be awarded the prize and so on. But it tells you a little bit about the history of the discovery of oxygen. And communicating this is a form of science communication which is really remarkable. I don't think it's very easy practically to do this. Now sometimes in the science too, I have one leg of the stool is data. Data must be good, and collecting good data is essential. Now one place where you can illustrate how important is in economics, especially in understanding all the economic indicators of the country. Nobody clearly knows what is Indian GDP. They keep on arguing about it. And some time ago, both the former chief economic advisor to the government, Mr. Subramanian, it turns out that every economic advisor is called Mr. Subramanian. So only the initials are different. Had a number, and the government had another number. Of course, this economic advisor had left his job. So they had two different numbers. He'd gone back to Harvard and he had a number from Harvard. The Indian government had another number, and everybody was arguing about it. You can see the Hindu was a very conservative newspaper. They said both Subramanian and the government may be right, because the data is all faulty. And we cannot use bad data in much of biology, chemistry, physics, and so on. The data must be absolutely true. Statistical analysis of data is important, and this is something that must be known. Now, for example, I was asked a question in the morning about the coronavirus vaccine. If you want to know whether the vaccines were efficacious or not, the answer is we need data. It's only have to have data, and then the data must be carefully collected. The experiment must be done in a controlled way. How would you test a vaccine? Not the way to COVID-19 vaccines were tested. The way you would test a vaccine is that you would have a population of people who would be given a vaccine, and another population of people who would be given placebo, and then the population will be injected with the virus. And then we'll see how many in this fall sick and how many in this fall sick. This could not be done during the coronavirus pandemic. You couldn't go around injecting people with the coronavirus. They have to get themselves injected naturally. And therefore, data sometimes is very important, how you collect it, how you analyze it, and the statistics that you use. There are many books on science communication, which one might do. Some of the best ones are the IISc, one of the best communicators. And he learns how to write a science article. And then he says, let go my method be only one. Like everybody follows. He says, literally, is like my chemical synthesis. Method be now to go into space and astronaut. And this is the first nine scientists outdoor. Lastly, some time ago, last year, the day before this conference, I happened to be giving a lecture in the university. And then I saw posters for this conference which was going to be there. You can look very carefully at all the people who are seated on the dais in this see that which we space being organized space space, air, water, and somehow seeing all of that we have done. Every single state and to this that is for solving environment. We want to solve after we stated the must be a solution that and so by in which public figures have put forward their positions on science. You will see that the degree in public science. The degree in science is educated at all levels. So that everyone can understand what is impossible to solve whether from energy or from environment if one technicality is any questions that we have generally?
Thank you so much sir, for this enlightening and thought-provoking lectures. Distinguished guests and friends, to my understanding, this is the last opportunity where all of us can meet the Balaram in real time. So please set your inhibition and interact with him as we request him for this practice session so that all of us get benefited with his vast intellect. So now the time for interaction and discussion.
Sir, I have a concern. This kind of leadership and this kind of statements from our leaders is the future of science in this country.
Okay, I can only say one thing. I'm glad I am not John. When you're old, you have to say the advantage that you're not looking forward to a. But if you're looking forward to something, I think one would like to see a far more conducive and more academic view of science than what we have. It is very much so practical. But you know, research is not enough. You also need to strategize and have a design of how you're going to solve the problem. This is not possible if you don't look at techniques. And funding for science going down, and mechanisms are deteriorating, and there's less and less understanding of. And here I would not blame the political leadership. Even among scientists, less support today for basics than there is.
So you said that funding is going down. But in the next sentence you said that the basic science where the funding is going down. So it's a fact. What the things are, all funding is there. Whether it's biotechnology or any other science subject. Don't you think that basic sciences need to be strengthened a little more? Because everybody has started forgetting about that.
Yes, I think there's a crisis also in teaching of basic science. Teaching also needs to change because the real problem that we have with the new generation of students is they have changed very much. They're completely different and they are used to technologies which were not there when teachers were growing up. Their attention spans are getting shorter, their access to information is larger. So teaching methods need to change. There is very little discussion on this in the teaching community. The other thing is that what we teach also needs to change. In each subject one needs to know. In fact, if I make a comment here, and I don't mean this in any negative way. If you take, for example, biotechnology, I'm old enough to have been there at the beginning, when in India the word biotechnology was being used. I was even then writing about that we shouldn't be doing technology which is important, all the disciplines of biology, and then understanding this is applied in a useful way and that becomes biotechnology. Today what has happened is that we have biotechnology departments everywhere. If you look at the kind of things which are being taught, they're pretty much the same things which will be taught in their across the world. And very often working techniques. That is, everybody when PCR was discovered, everybody was teaching PCR.
Starting to tissue culture.
Yeah. And when now CRISPR-Cas9, everybody is teaching CRISPR-Cas9 and thinking. What they don't realize here, the teaching of biology is these are the techniques. Whereas this in other subjects like physics, chemistry, this is not happening. We know techniques for what they are. We don't confuse a technique with the entire science. But in biology, this is happening. I think that's something that might change when people begin to acknowledge it. That doesn't mean government. Sure. Thank you.
Sir, this is Professor Balaram from one of the sister institutions here. I have a concern and a question. If I refer to one of your slides where you had shown Sir Sriram, the sole laureate 100 years ago, the country has produced. Now, 100 years have passed, we claim that we are progressing in science, but the only scientific distinction country has earned is 100 years back. No Nobel laureate has been produced by this country since last 100 years. Although we know that millions and more such distinctions, but they are more in from this land, and others. Secondly, my concern is that we have been failing to internationalize our education. If you see in a global context, now, if you see the 2022 quiz or type education ranking, even your own institution, the most of the best in the country is beyond 200 bracket. And you see the small country of the neighborhood, the National University of Singapore, that's fortunate. What is your take on this? What is ailing our system? Where we are going?
I this I would, because I answered this question, or heard this comment on this many times as to why India hasn't had a Nobel Prize after CDR. That question you have to address in Nobel. Not to anybody. The other thing is, I think we should use the Nobel Prizes as the criterion for judging the science. They don't shine this problem in China. China is no lesser than US now in many ways. It's going to be harder. You see, out of the hundreds of universities in the United States, which are above the universities in the ranking, they don't have any Nobel laureates. That's because the enterprise is very large, and you are unlikely to get X by accident. Today, by accident, if you get a Nobel Prize, you may get an accident because somebody may find something. Okay? You may get a Nobel Prize. It will not make any difference to India. It will only be momentarily for a couple of days. It will be like Neeraj Chopra getting gold. Doesn't change sports or cannot get long ago. I don't think these should worry too much about this. Rankings, I think we should. Rankings, in 2003, first world rankings which were from university side and which are now called AR rankings. At that time, they were called Shanghai rankings. And since rankings are so many times, I might have been the person who read the ranking because I wrote it in France. Nobody, I was nobody worried about it. I would have even been happy because Indian Institute of Science was top Indian institution in the rankings. And there were two Indian institutions which were there, two IISc. But at that time itself, I realized I could make one wish that the next year when they did the ranking, the IIT is also top. This is the concentration doing that. The parameters used to the rankings are such, then if we judge the health of a country by the number of people who are above a certain height and certain points we give, then it will turn out that many countries will be healthier than India. I don't think it makes any difference. So parameters are hugely important. But as these rankings go on, they become a game which everybody is trying to, like your NIRF rankings. The NIRF rankings were introduced. This is like, if I can't play that game, I will play my own rules. Okay. So new game was created. Your own rules. So there are parameters now which rank. So you get an institution which is number one in the NIRF ranking, but lower in the rankings which are done by
education or ranking.
yeah, because they use different parameters. And you will see that every institution will not try to go up with the ranking. This is impossible. So how will go up and it's not something we can address.
So there is an important point that we are not living in isolation. We are not living in isolation, we are living in a globalized world. We are talking in a global context now. How the world is looking at us.
The world is looking at you, but the world is looking at you in real terms only in terms of what you produce. Even if you produce publications, you produce 10,000 terrible publications. The world isn't going to look at you well from the number 10,000. But if you produced 1,000 which are very good, those 1,000 which everybody will look at. India is looked at reasonably well in some areas. It's again only some people. See, science is now a huge enterprise, and especially in fields like biomedicine, all biological sciences on the border of medicine. The American and European and Chinese enterprises are simply size of colossus compared to what we have. No, basically we are not as advanced in these areas as we should be, or we would like to be.
Sir, you have a vast knowledge of organic chemistry and biology also. So what is just this size question, sir? What is the origin of life? Origin of life, is it because of biomolecules, organic molecules come to us?
What's the origin of the first cell?
Yes, yes, sir.
Not a question which has really been answered. Like one does not know what is the first cell. We don't know how the first cell originated. Hypotheses. But hypotheses don't necessarily have to be accepted. Hypotheses are good only if they can make predictions. In the origin of life kind of that you can't make many predictions. There is no fossil record. So cellular evolution. What people are really working very hard on now is to look at what might be the last universal common ancestor, that is before the division of the bacteria from the eukaryotes. For that there is actual experiment and work which is going on, but not on the first cell.
We have seen of students and young researchers from India to abroad in terms of academic and research. So there is a shift of our young researcher, young mind towards international forum. So how we can contrast it and what we can do for this so that we can have our own culture, our own young.
So first of all, we have many more students than we can infect in all institutions. So it's natural that competition for admission becomes very difficult, and it's easier to get admission abroad than get admission in some Indian institutions. Secondly, admission procedures in Indian institutions are examination based, and many people who are really interested don't do well in the examinations. And I mean, CSR net, I didn't say it this way, CSR net cannot be the deciding factor for motivation and interest the student has. Unfortunately, many students who would be very good in research, we see a lot of those students. I've seen over there many students, they come and do projects in Bangalore. After they do projects, the same students will go to Germany, Japan, UK, sometimes to the United States, and then resurface after years of PhD and postdoc, and now become faculty members in the West. So it's a very strange thing. I think that's all this with all of us. We don't have good ways of admitting people. There's no confidence in anybody. So we need to have an impersonal, machine-judged examination. Students will go. Difficult to get.
So there should be some balance where we can, like this examination system should be challenged or something. Like how we can go for it. What should be the
Well, yes. See, challenging the system in India, one thing is that the system is, and I know this for years, the system is practically immovable. You actually don't challenge the system. You try to find ways of tunneling under the system, going around the system, to do whatever you want. Somebody, I don't know, maybe it will make no, somebody mentioned report finds, the only thing I can guarantee when the report is submitted is that it's going straight to the waste basket. And it doesn't happen. So I hope that the examination system will ever change. I think intrinsically have the ability to communicate. And what they need to learn is really to communicate in the simplest possible words. Scientific concepts that we are trying to make people understand. This comes only by practice. One can write, one can speak, and today I think there are much better ways. I'm too old to learn all these things. I would like to do for it. I tried for a little while. There's podcasts which have come. Then one can even do videos and all if one has the thing, because I have participated with students in some videos once which were made. There are many ways of communication. Now, you should be looking at them. I think there are lots of people now. I think it's also important to communicate in other languages other than in English or to get this thing. For example, you tell me if I say cows breathe out oxygen, and people actually believe that cows breathe out oxygen. How would you convince them that cows breathe out oxygen? You have to think very hard for that. It's not easy. A chief minister's word over your word. So the job of a science communicator in an environment like ours, particularly if you go to more and more global places, is difficult. It's not easy. One of the things that I would advise anybody who's young and wants to get a broader view is start reading. And read those things which are not useful. They shouldn't be used in tomorrow's experiment or in tomorrow's examination. Read other things. There must be time set aside for reading those. Maybe not every day, but whenever the opportunity arises, you must read. And over time, if you keep reading, you will develop your own interests. You might like some aspects of science writing. There are some wonderful science writers now who have been writing for years in biology, in physics, in chemistry, and so on. And it would be worthwhile to read. Then you're interested automatically. And also sometimes you must ask simple questions. In research, you ask very complicated questions. Usually complicated questions have simple answers, and simple questions have no answers.
First of all, I would like to thank you for a scintillating lecture. But I was just wondering that how critically you're reading this. That is really very commendable, and that is a take-home message for all of us. I think that we need to read in a very critical way. Not really, but not so critically. The way you lecture and
well, I think reading as a hobby cast are two different things. Reading as a hobby means it's the hobby. You're indiscriminately reading something or the other. You get into this.
Sir, once you had one interview of those was on the impact factors.
Yeah.
So, what's your take on the impact factors right now? These days when we are supposed to, increase the number of publications, just satisfy the APIs and all.
Again, I must say, as far as scientific is concerned, I don't take credit for many things. Two things for which I like to take credit, but nobody gives me credit. One is to be the first person to write rankings and not write well about them. And I'm also the first person to write scientific. I was always an admirer of Eugene Garfield because I read Eugene Garfield's work right from my younger days. And Garfield came once to Bangalore and I was in the audience to listen to him. He's the man who developed all the methods of scientific, the citation index, the impact, journal impact, and everything. The impact factors were, Garfield never intended the impact factors to do what they are doing today. I have given lectures in many places, including Indian National Science Academy, which should know better but doesn't. Don't use all these. Because if you look at the history of the impact factors were introduced by Garfield to help librarians. In the old days, we had limited amount of money to buy books. In America, college libraries required a limited list of journals to buy. And Garfield found this method of classifying journals on the basis of what he called impact. What is that impact? He took a list of references in journals and see in the reference list how many times do journals appear. If nature appears more times, then nature is more impactful. That's all he did, that's only the factor evolved. Today, what you are doing is you are using the impact, every journal is gaining the impact factor. Today, good journals have a lower impact factor than journals in which I would never publish. And publishing is now, again, I don't know if you are PhD students, but publishing now is science publishing is the biggest scam in the world. It's not a scam which is restricted to one country. It's a universal scam. And every journal takes money. You will not have money to pay for all the publications. And I know because I am retired, I don't have any money unless I spend my own money. So today, if I want to write a paper, I search for a journal which doesn't charge anything and send the paper there. Of course, no one's going to ask me which impact factor journal you publish. So I don't care. But I realize that it's very difficult for younger people. The impact of a paper must be judged by the number of people who read and who use it and who cite it. Not the impact factor of the journal which it was published. See, the way the impact factor is calculated, I can tell you, the late 1990s, early 2000s, there was a study done at IISc. The then director had commissioned citation analysis for which he paid money. The results came, and I was given the results to read and analyze. And the one conclusion that I drew was that first of all, the lists should not be publicized. Second is that what did our papers do? If our paper was published in a very high impact journal, it got less citations than the average of that journal. That means it was pulling down the impact factor. But if our paper now published in a medium professional journal, we were drawing more citations than in the and our papers were raising the journal. Actually, even if I come to NCBSin, I don't read it. Because sometimes when the library subscription doesn't come, only some old guys like me will ask the librarian, why is it not accessible to us? In an issue, you won't find more than one. You may not even find the paper here. But if you go to a professional journal, same field as one paper, you'll find at least one or two papers of interest. This is no.
I'll ask them one by one. First question is, what is your opinion on the scientific temper of scientists world over and in India? I mean, when I see scientists wearing all kinds of stones or portals, and I see them across the board, so I just wonder what kind of a science is being
Even
done.
scientists, temper among scientists.
Yes.
The scientific temper among scientists is no better than the scientific temper amongst the general population. It's absolutely no difference.
So it's a dangerous challenge when scientists are
In their again, I don't know, it's quite science. See, people believe in, people are superstitious, believe in rituals, believe in this. Don't think it does too much damage when they are not causing any damage to other people. Okay, as long as they are keeping it to themselves.
but for them they don't have faith in what they are doing.
No, that is what is very interesting. In India, I think I've seen many scientists who, these two things are totally separate. Even in America, there are scientists who are totally separated as far as what they do in the university, what they think outside, two compartments. That's okay. No one should tell someone else.
Sir, and the question I have is, normally, I know about India, the student, when he or she comes to research, the main aim is to get the job. And there's dearth of jobs. So, less and less people are, and they take it as a stopgap. Till they get something better, or in the meantime, if they get. So, I don't think mentally they are prepared to do science. Because at the end of the day, everybody would want bread on the table.
No, I think the onus is also students come to do research for various reasons. One is in India, by and large, the longer you see the university, the more secure you are, rather than going out into the world. And by the time you get to PhD, you may even get a scholarship, so you're comfortable. I don't think every student who comes to research necessarily knows what they want to do at that time. So I think it's incumbent on the institution to help students to find out what it is that they want to do and to encourage them to do the best they can in that process. But many of our institutions, in fact I think the best of our institutions have a problem. Most faculty believe that the students are there to do their work. And this is not true. In our PhD system, there is a great educational component which is needed. So, student and supervisor together must learn whatever is to be learned during the course of research. I think supervisors and departments have great responsibility to boost morale. Morale is low in many places.
There should be some kind of counseling set.
I don't know if you counseling, sir, I think they should be here. Someone asked me in the morning about inspiration. You need people who inspire you. On the teachers, in colleges have that sometimes. There are teachers who are inspirational in colleges. Students go to something because of that teacher. Each have a huge responsibility.
Sorry, what is the content?
Scientist, Director, School of Biotechnology, Professor Saina Coleman, and Professor R.M. Goy, who present a token of gratitude to Professor Balaram. Thank you, sir. Now I request President IISc and HOD Botany, Professor Venupal ma'am, and Vice President IISc, Professor Jyoti Babu ma'am, to kindly present a token of gratitude to Professor Hemlata Balaram, and I request Professor P. Balaram to receive on her behalf.
Okay, sir. Okay, you can see. You can give it out. It is announced.
Okay, it's announced.
Thank you, sir. Thank you, ma'am. Thank you, sir. As we come to the end of this event, I would like to invite Professor School of Biotechnology, Professor Jyoti Babu ma'am, to extend a formal vote of thanks.
Thank you, Karan. I'm very short. Thank you, sir, for accepting our invitation, and for the want of better word, I thank you. I don't have a better word. I'm sorry for that, and I also want to thank you for being so approachable. I've never seen students asking questions so uninhibited as I saw them today. I thank Professor Goyal, Professor Paul, Dr. Sanna, Professor Goyal for always being associated with us and taking time to interact with us. Professor Cole for taking the leadership role in organizing this event. He was very forthcoming. Dr. Sanna for always being there, making all the infrastructure and resources in the department available to conduct this event. I thank faculty from the colleges and the students. Thank you so much for making this event successful by the participation of the students. I thank faculty of the Botany, Zoology and Biotechnology for participating and working behind the curtain. And last but not the least, I thank students and scholars